Hello, my name is Brian Fetz. I'm an engineer at Keysight Technologies. In this short video, I'll introduce you to an exciting development in the industry, the USB Type-C connector. It is low profile and orientation independent. It sports many pins for broad applicability and supports high current charging. As if that wasn't enough, it also allows multiple protocols such as USB 3.0 and 3.1, DisplayPort, and Thunderbolt. Let's start with the USB Type-C signal plan. The first thing you'll note is that the interface is symmetrical. On either side we have ground pins, and towards the interior we have our V-bus pins. This allows for the high current charging, specified up to 5 amps. The next thing you'll note is that there are two pairs of TX-RX differential lines. We'll call those port 1 and port 2 respectively, and you'll note that if you flip the interface over, TX2 lines will land exactly on the TX1 lines, and the RX2 lines will land on the RX1 lines. In the interior of the interface, you'll see that we have USB 2.0 lines, and they are duplicated. There are two D plus and there are two D minus. These are actually cross-connected at the receptacle in the interface. There's a pair of utility pins, SBU1 and SBU2, and these are used for alternate interfaces other than USB 3.0 and 3.1. They're used for DisplayPort as well as Thunderbolt. The magic of the interface are the CC lines, denoted here as CC1 and CC2. You'll see that on CC2 we have a pull-up resistor to VC. The same is true on CC1. This pull-up resistor is sensed to determine if there's a load on the other end, namely RD on the device. When that is sensed, then it knows that the particular port that that CC line is connected to is active. In this case, it's CC2, means that port 2 on the host is active. Since I have this shown that CC2 on the device is connected, then port 2 on the device is active as well, and you'll see we have a direct connection, and the link will be determined on those two. If you should flip the cable over at the device, then CC1 will be connected to the CC2 of the host, and now port 1 of the device will be connected to port 2 of the host. That's how it gets its orientation independence. You'll notice on the interior of the cable I have resistor designations RA. And when a cable is connected, one of the CC lines will be connected to this RA termination, and it'll indicate that that CC line is to power the cable locally. The CC line, upon connection, will become VCON. VCON is a voltage source for the cable for that local port, but does not go through. The cable only has one CC line, and that's how the orientation is determined for the link. It's a sophisticated interconnect that requires high bandwidth. In this case for USB and for DisplayPort, 20 gigahertz, 30 gigahertz for Thunderbolt, as you press 20 gigabits per second through that interface. There are two RX-TX pairs, so both of these need to be considered in a validation plan. If the device that you're manufacturing has different protocols, such as DisplayPort as well as USB or Thunderbolt, then those protocols need to be tested as well. When you are powering up the device, initially, you'll need a means to control the CC signal through the RP, RD, and the RA terminations. And this helps in debug and is also useful in test for control of the ports. You'll need a means to observe the CC lines, V-bus, and the SBU lines if you are using an alternate mode. You also need a means to communicate over the CC line the requirements of power in the link. V-bus can be set up for your device as a consumer or a provider, and it may have different voltage or current requirements, and that may need to be negotiated through a power delivery controller. Also, if you're testing an alternate mode, you'll need to be able to get that device in the alternate mode, and that has to be done over the power delivery channel as well. As power delivery is incredibly important in this interface, You'll need to be able to test the communication channel, that is the line over the CC, its protocol, and the VBus profile. If you'd like to have more information on Keysight's TypeC solutions, please visit our website. Thanks for watching.